Pleasure to be here. And, well, just to show off a bit, this is the reports Carl just mentioned. A quick presentation, and I'll also leave you with a short video. So I'll leave the boring part for later, essentially. This is a quick information about the program. We started working on plastic-related issues 5 years ago. Initially, we started in the Azores with a research project related with establishing a baseline for contamination of commercial fish species. Then later we evolved the research into shearwaters and turtles. And then we focused on the Baltic and on the Mediterranean, trying to quantify the total amount of plastic. And now these two projects, the Mediterranean and the Baltic, are about to be finalized. We have an ongoing project called Mar Plastics in two regions, southern part of Africa and Southeast Asia. And we'll be kicking off in, well, very soon, big project in small island developing sites, 6, 3 in the Caribbean and 3 in the Pacific. This just to give an idea about the projects we've been doing in the last 5 years. So I will leave you with a short video.
Our over-reliance on plastics has seen large quantities leak into land, rivers, and oceans, causing harm to marine environments across the planet. Small pieces, less than 5 millimeters in size, are known as microplastics and can be classified as primary or secondary depending on their source. Primary microplastics spread in the environment through spills and misuse. Secondary microplastics break up from a wide range of pieces of mismanaged plastic, eroded by sun, wind, and waves. In 2017, the International Union for Conservation of Nature released the first report of its kind to identify the different sources of primary microplastics.
There is the visible and the invisible side of marine plastic pollution. The visible is coming from mismanaged plastic waste, 8 million tons per year into the oceans. The invisible comes from these primary microplastics. They come from different sources like the abrasion of tires, the shedding of textile fibers during washing, the loss of microbeads from cosmetics, or the abrasion of different plastic objects or paints. And what we discovered is that these primary microplastics are a very significant source of plastic into the oceans, with an additional 1.5 million tons input every year. Overall, this is around 15% of all plastic into the oceans that come from the microplastics. And this is even a higher proportion in more developed countries with better waste management facilities. For these countries, these primary microplastics even outweigh the contribution of mismanaged waste. We need better tools to measure the plastic footprint of companies and countries in order to close the plastic tap.
What is important to remember is that plastic in all forms, all shapes, all sizes impact ecosystems, some more than others, like marine ecosystems. With the support of the Swedish Postcode Foundation, we started a project in the Baltic region. We also conducted experiment fieldwork in Canada, Sweden, Finland, with implications for the Arctic.
The Arctic region is essential for global climate regulation. Here, temperature and salinity variations cause surface currents to bring warm water, while the denser, colder water returns south. Floating microplastics aggregate in the Arctic, where they are trapped in sea ice. IUCN suspects that microplastics might interfere with the formation and melting of that ice. Covered in ice and snow, the Arctic has high albedo, meaning it reflects solar radiation that would otherwise be absorbed by the ocean. If a dark piece of microplastic is trapped in the ice, it will convert the sunlight into heat and melt the area around it. This could reveal darker surfaces, absorbing more heat and creating a self-reinforcing effect. During the melt, phytoplankton rise to the surface to photosynthesize. This attracts zooplankton, which ingests some of the plastic particles released by sea ice melt. Microplastics then enter the food chain, causing unforeseen consequences for life.
Part of the research we're conducting aims to understand the implications of plastic in ice formation and melting. This is why we partner with the University of Manitoba, trying to understand the possible impacts of plastic in the ice.
In the last few years, what we added to our research tools was a new facility called SURF, or Sea Ice Environmental Research Facility. It is essentially an outdoor swimming pool that's located right on the campus of the University of Manitoba here. We start to formulate the seawater into this pool, and that water starts to freeze.
We increased the concentration of plastics, so we could understand does plastic impact ice formation. How much plastic is scavenged when ice forms, where these plastics will be distributed throughout the column of ice. And is there a point where concentration of plastic starts to affect the albedo effect? This is a control environment, which is nice, but we needed a validation. That's why we set up an expedition around the Botnia Gulf, going to Sweden and Finland to collect samples and see how plastics are embedded in the ice during the ice formation. So we basically collected some ice cores and we shipped it to Canada. So the idea is that we correlate these samples taken in the Botnian Gulf with the experiment that was carried out in Canada.
The geography of the Baltic region is very sensitive to pollutants since it is an enclosed sea, and the pollutants stay in the water for a very, very long time since it takes almost 30 years for the water to renew itself. The Postcode Foundation is interested in this research in order to see how it can be applied in the area of climate change and eutrophication, and also to identify the entry points into the system and to see what damage microplastics can cause.
It's fundamental to treat the plastic issue not just as a recycling problem, but also beyond that to look at how do we manufacture products, how do we actually design them in such a way that it won't automatically end up in the ocean. Our objective is to bring the latest science and apply it in such a way that it really makes a difference for conservation.
Okay, now a quick introduction about the project was already done in the video. The goal of the project was to basically generate new scientific data that could be shared and used by stakeholders. Ultimately, we aim to restore the health of the ecosystems and biodiversity after we understand the main impacts caused by plastic. So the project had 5 main components. We thought that was the best idea to divide them as such because there were missing information, and we need to have an analysis of the gap of information that was missing. So the hard part was not so much to carry out the individual chapters of research, but then to link them in a coherent way. So the first one is quantification, where we try to basically understand how much each country and each sector and through each pathway and what type of plastic is reaching the Baltic Basin every year. Second one, as it was seen on the video, relates with the possible impacts of plastic in ice formation and ice melting. The third aspect was we tried to understand and basically doing a review of present literature for some of the species that are considered endangered in the Baltic, if there was already some indications about the impacts caused by plastic. Fourth, we sent a questionnaire to 150 companies around the Baltic to get some feedback in terms of awareness from these same companies that represent around 50% of GDP in the Baltic region. And lately, at last, we did some policy gap analysis about Baltic marine marine policies around marine litter from the Baltic states. So, quantification. Briefly, we developed a methodology or a tool that expands beyond the life cycle assessment. So we're trying to understand the full impacts upstream and downstream from specific products, not only from the production phase, but usage phase, transport to retailers, and eventually after the use phase, the end of life. So trying to understand and bring all these externalities from the product and to understand what is the impact of this type of product. So the whole idea is that we can measure specific products and sectors. At this first step, the tool will be basically measuring impacts at marine, in a marine environment, not terrestrial environment, and we will not address biodiversity impacts or human health impacts at this point. To give you an idea what that type of data that can be generated through this tool, for instance, you have the total leakage, in the example in this case for Lithuania, of a plastic bottle versus a glass bottle. And you can see there's still impacts related with plastic for the glass. And this comes mainly from transportation. We can also generate, for instance, in this case, data for the production of one single piece of textile across different countries and trying to understand the losses and leakages across different countries. We can also simulate, and this is mostly modeling based on the products that you see every day, which are the ones that you can actually find and at which depth. And the idea is stemming from, for instance, the European strategy framework that was based in the most common found items along shorelines, but this gives you an idea about objects that actually float and not about the ones that sink. We can go and start to expand a bit more on the work that was provided by Jenna Jambek, where she analyzes populations up to 50 kilometers from the coast. But in this case, we're missing a lot of population that lives on the watershed, everything that is carried by the rivers and population that live in this watershed. So we can go and use the tool to calculate more precisely hotspots for pollution and accumulation. In this case, we can also calculate per country and per sector, not only waste generation, but associated leakage. So the main findings of this report, because we will publish this report very soon. It's a report about the methodology, how do we build the tool, how does it work, trying to explain all the equations, all the modeling that is behind, so it's not like a black box. We launched the report, and we'll be launching the report with 3 case studies, one for textile industry worldwide, second one for packaging, and the third one for the Baltic Basin. So the main findings were basically the total amount of plastic that is being leaked every year for the Baltic Basin, with a special incidence from Russia's side, although we only consider part of the population that actually lives in the vicinity of the Baltic. Private sector, this is where we basically, to achieve change across various sectors and stakeholders, it's vital to not only focus on determine the status quo, full scale and sources of plastic pollution, but also determine what policies and solutions would work to tackle this pressing issue. So in a way to understand the feeling from private sector, we sent a questionnaire with a couple of questions to the private sector and waiting for their reply. Most of the questions were, the questionnaires were mostly sent to private sector, and we received lots of replies based on these questions, basically what they would foresee as potential solutions that could be used, or it's already being used at this moment. And actually received a lot of responses, but they were not in a way classified. So once we received most of the measures that private sector was using to tackle the solution internally, we tried to speak with them and classify them by effectiveness. So we defined these 10 most effective measures being taken by companies to address from within the problem of plastic pollution. So this is just a summary about all the information we gather from the questionnaire. Then on the report there will be all the rest of the information. Now, third chapter, climate change. We thought it was relevant to bring this issue because no research was ever done on the possible impacts of plastic in ice formation and ice melting. So for us, it was very curious to try to understand if there was an entry point in terms of discussing the impacts of a deposit of plastic in the polar caps, especially in the North Pole. So we launched the research. Was very interesting. Actually, we end up having more questions than the ones we actually initiated, which was kind of interesting. So main findings from the research, and this will be published maybe next week or in a couple of weeks. It was accepted this week for publishing, is that most of the plastic is distributed in the upper fraction. Doesn't affect high salinity, but affects brine. Sorry, it doesn't affect the temperature, but affects salinity. And by affecting salinity, also obviously has an interference with brine channels. And brine channels have a major role when it comes to exchange of greenhouse gases between the atmosphere and the process of mineralization of carbon dioxide. So this is starting to have more questions than answers. One of the results we were not really expecting was the albedo, but let me bring you to the next slide, was the decrease of sea ice albedo, and this was most probably because we didn't make a clear choice of color, and we didn't understand when we started to design the research that we should have separated these by colors to understand the different absorptions from the different colors of material. So actually we were expecting to have a reduction of albedo, and we had an increase of the albedo effect, meaning the radiance that is reflected because most of the plastic stays at the top shelf of at the top part of the fraction. So this is a quick overview on the results, and this will be published in the Marine Pollution Bulletin in 1 week. Skipping to biodiversity impacts, what we tried to do here was to understand from the point of view, because IUCN has a red list and ELCOM has a red list for the Baltic species, trying to understand what was the status of research regarding specific species, edible and non-edible species in the Baltic, and trying to understand where the research was not done for one specific species, although it was appointed as endangered species, if there was a proxy that we could use to understand if the same feeding patterns can be observed between the two species, those would be endangered or not by the consumption of plastic particles. And this is basically to foster the discussion of using plastic as a threat indicator for species. Policy, last chapter. We did basically a gap analysis because due to the terrestrial origins, transboundary drainage, and high mobility once at sea, marine plastic litter is a challenge that Baltic Sea stakeholders must tackle in concert. Now, there is some sort of dissonance across the policies, across the Baltic states, and this is what we try to aim, and obviously the results will come out on the first report. Conclusions to finalize. I always like to end up with ways to move forward, and the whole idea normally is that I bring presentations with no more than 3-4 slides. This time I brought around 30, which is too much, but mainly bringing the points that we end up when we have this discussion about how to move forward, and bringing the most important for us some conclusions or ways to move forward that might have some political implications. Namely, the first one, when we have the discussion about capping the production and using a maximum amount of virgin material to foster recyclable market, for instance. So the last point that was discussed, the policy regarding the project, was the harmonization of policies around marine pollution, and obviously stirring and spurring and financing innovation around what might be seen as ways to move forward. In this case, talking about mechanical recycling, bio-benign design, eco-design, the right choice of materials, self-degrading materials, self-healing, for instance. I had the chance to speak with someone this morning at KTH about self-healing coating material, bio-based and biodegradable. So basically this is the quick presentation about the project itself. I'd like to thank once again to the Plastic Swedish Foundation. The Swedish Coast Boat Foundation for the support in this research that opened much more doors. It's a bit difficult to explain in such short amount of time the spin-off effects that this project will have in different areas. For instance, the tool that we will be basically using will be used across 13 case studies together between IUCN and UNEP. We will try to validate this in 13 countries in terms of quantification of waste generation, plastic waste generation, and leakage of plastic, and see and validate the model, for instance, just as one of the examples. So, thank you very much.